At the heart of Cranfield, based in England, lies ZeroAvia's research and development facility. This is a company focused on developing hydrogen electric solutions to address a variety of markets in the aviation industry, like commercial passenger transport, package delivery, agriculture, and more. Right here is where the world's first hydrogen electric commercial plane was being developed before its inaugural flight, which occurred on the 24th of September 2020. The entire 20-minute flight consisted of a taxi, takeoff, full pattern and circuit landing. After takeoff, it rose to 1,000 feet, garnering a speed of 100 knots and flew for 8 minutes. It covered a total of 19 miles, leaving nothing behind it apart from water vapor. This is ZeroAvia's hydrogen electric Piper Malibu Mirage. Now, several hydrogen-powered experimental aircraft have already been developed within the past. What makes this plane unique from the rest, however, is the fact that it's of a commercial grade. These can be used for fare-paying operations, such as passenger flights. The aircraft, which is currently the largest of its kind, had its airframe manufactured by Piper Aircraft, a general aviation manufacturing company. It was originally powered by a Lycoming 540 series piston engine, which contains 6 cylinders and produces a horsepower of 350. These take in leaded aviation gasoline, which when burnt, produces harmful substances like carbon dioxide and lead compounds. ZeroAvia replaced this with the 800-volt emission-free powertrain, consisting of hydrogen fuel cells, electric motors, inverters, and hydrogen gas storage. These components are integrated using proprietary hardware and software, which runs the powertrain and interfaces within the aircraft systems. ZeroAvia has partnered with the company Intelligent Energy, which optimizes its high-power fuel cell technology for application in aviation. A hydrogen fuel cell is a device that takes in hydrogen and oxygen and uses them to produce electricity and heat through a chemical process. The only byproduct is water. The aircraft's power is delivered through 2 subunits with dual redundancy. This consists of 2 inverters, 2 motors, and 2 fuel cell stacks. Dual redundancy is when components of a system are duplicated, providing redundancy in case one should fail. This makes it safer and much more reliable. The compressed hydrogen system also has integrated safety in tanks. This consists of integrated safety valves, flow limiters, and automatic shutoff by temperature and shutoff by flow, which can be essential in preventing hydrogen leaks. The retrofitted Piper Malibu Mirage weighs about 2 tons and stands at a height of 3.4 meters. It has a length of 8.8 meters and a wingspan of 13.1 meters. It can accommodate a total of 6 passengers, including both the pilot and the co-pilot. This makes it viable for commercial operations, particularly in a business class setting. The plane's development was funded under the UK government's Aerospace Research and Technology Programme as part of the High Flyer project. The High Flyer project's aim is to decarbonize medium-range small passenger aircraft by demonstrating powertrain technology to replace conventional piston engines and propeller aircraft. The project initially received funds worth £2.7 million, which was equivalent to $3.3 million. As part of the High Flyer project, ZeroAvia has partnered with the European Marine Energy Centre, placing an entire hydrogen production, storage, and refueling system on the grounds of an airport. This hydrogen airport refueling system offers a microcosm of what a hydrogen airport ecosystem will look like. Using hydrogen produced from local renewable energy is a practical way to enable zero-emission flight. This is known as green hydrogen. The companies are working to set up this network, powered by near-site renewable electricity, which can be generated by wind turbines, or on-site renewable electricity, which can be generated by placing solar panels in the empty fields between runways. A battery will be used as a buffer, and an electrolyzer will feed off the grid of the renewable energy source as it runs full-time to produce hydrogen. This can be done through water electrolysis, which is basically the splitting of water into hydrogen and oxygen using electricity. The hydrogen is then compressed and stored in 350 or 700 bar gas tanks. Afterwards, a hydrogen refueling truck will arrive and take in a certain amount of hydrogen on board and roll around the airport as it fuels the airplanes. This hydrogen is injected and stored as compressed hydrogen in gas tanks that can be mounted on the airframe externally. Oxygen then enters the powertrain in the form of airflow, and both of these elements head into the proton exchange membrane fuel cell to undergo a chemical reaction which produces electricity. This electricity then powers the electric motor, which provides rotational energy for the propeller, generating enough thrust and causing the airplane to take flight. The only byproduct is water vapor. To enable the innovative project to be delivered, the European Marine Energy Centre awarded a contract to Fuel Cell Systems Limited to supply ZeroAvia with a redeployable electrolyzer, which produces hydrogen and a mobile hydrogen refueling truck with 55 kilograms worth of hydrogen gas storage. They also took delivery of a Toyota Mirai, which is a fuel cell car that will be used for ground operations. Val Miftakov, the founder and CEO of ZeroAvia, believes that with 50% of all trips worldwide being covered by the 500-mile range, this is the sweet spot for developing a new, disruptive regional aircraft.